Hello guys, this is Jiten Jain and this is our 6th signal and system lecture. In this lecture we will discuss about LTI system. LTI system is linear time invariant system. So any LTI system is always represented with its impulse response, as we know. Suppose LTI system has impulse response h of t and we provide input x of t, output we got output y of t. Then output relation between input and output is y of t equal to x of t convolution with h of t. Okay, so if we perform convolution between input and impulse response, we will get output. Okay, so this operation is called convolution. Okay, this is not multiplication, this is convolution, which transform into multiplication when we convert into frequency domain. So this is convolution in time domain. So here y of t is output, x of t is input, h of t is impulse response. So what is impulse response? What is h of t? Impulse response is a characteristic of any system which is output of the system when impulse function is applied as input. Okay, means if we impulse, by name it is clear, impulse response is response due to impulse. Okay, if we provide input as impulse function, we got output as impulse response. So the formula for convolution is x of t convolution with h of t equal to integration minus infinite to plus infinite x of tau h of t minus tau d tau. Okay, in continuous case. For discrete case, integration replaced with summation. Okay, and I change parameter also, tau replaced by k, t replaced by n. Okay, so okay, so above operation between x and n is called a convolution. I already told you. So why we perform convolution? Convolution is used to find the zero state response. As I told that convolution is used to found output. Okay, but exactly convolution is performed to get output with zero initial condition. Okay, when we use convolution, we assume that initial condition are zero and we got output. So convolution is used to find the zero state response. Okay, here we assume that all initial conditions are zero, so only for a given input we found output using convolution. And convolution is cumulative also, means y of t equal to x of t convolution with h of t equal to h of t convolution with x of t. Means here in this formula you can interchange x and h. Okay, you can write it h of tau x of t minus tau d tau also. So how you find convolution? There are several steps. That to find convolution of two signal x and h, follow the steps shown below. So first of all, if you see the formula, what you have to do? First of all, you have to replace t by tau in both signals. Okay, so means that you have to find x of tau, h of tau. Then what you have to do? Then you have to fold one signal, like h of minus tau. You have to fold one signal, either x, either h. If you fold h, means you fold h means h of, you find h of minus tau. Then you have to shift h, okay, by t. H of t, you get h of t minus tau. Then you have to multiply these two signals, x of tau and h of t minus tau. Then you have to integrate it. Okay, I written those steps here. First of all, change the variable t by tau. You get x of tau, h of tau. Then fold any one signal, say h of minus tau. Say you fold h, then you will get h of minus tau. Fold means you have to perform time inversion. Then you have to shift the folded signal by t. remember you have to shift that the folded signal only. Okay, h of t minus tau you get. Then multiply above shifted signal with x of tau, means you have to multiply these two signals. You will get x of tau h of t minus tau. Then you have to integrate above multiplied signal, okay, with respect to tau. Okay. Then there are two methods to evaluate convolution. First is graphical method, second is mathematical method. Okay, so we can use any of these two methods. Suppose I will explain graphical method using this example. Suppose we have question, find y of t of equal to x of t convolution with h of t. Then here x of t is given e to the power minus 3t u of t, and h of t is given equal to u of t minus 4. So using graphical method, what we have to do, first of all, we have to draw these two signals. Okay, if we draw, we will get like this. Okay, this is x of t, this is h of t, this is e to the power minus 3t u of t. Here at 0 its amplitude is 1, and this is u of t minus 4. Okay, its amplitude is 1 after or equal to 4. Or then first of all, step 1 is you have to find limits of yt, means convolution. Yt is convolution of x of t and h of t. So you will get limits of yt. So what will be limits? Lower limit will be sum of lower limit of these two signals, and upper limit will be sum of upper limit of these two signals. Okay, so range of yt will be sum of lower limit less than t less than sum of upper limit. This will be lower limit of yt, this will be upper limit. You will get lower limit, here it is 0 and here it is 4. So 0 plus 4 less than t less than, here upper limit in both signals infinite. So you will get range 4 to infinite of yt. Okay. Second step, so first step was limits, you have to find limits of yt. Second step, change of axis form. So you have to change t by tau, you will get like this. Then you have to fold any signal. Suppose you fold h, then you will get h of minus tau. Then you have to shift this folded signal, you will get you can shift it. What you have to, you have folded, then you have to shift this folded signal by amount t. So if you shift this folded signal, you will get two cases. First, you will, if you shift the signal, this limit will be, this value will be t minus 4. So if there are two cases, t minus 4 might be greater than 0, might be less than 0. Suppose case 1 is t minus 4 is less than 0, means t is less than 4, means this limit t minus 4 is below before 0. You will get like this. Now you have to perform multiplication of these two signals. You will get 0 overlapping, means multiplication will be 0, then output will be 0. Second case is this lower limit t minus 4 is after this 0, means t minus 4 is greater than 0. This was the second case. So means t will be greater than 4. This case look like this. So this value is t minus 4 this time. So if you multiply these two signals, you will get some value, not 0. Okay, so now you have to perform integration of multiplied signal. So lower limit will be 0. Okay, if you multiply these two signals, lower limit will be 0 and upper limit will be t minus 4. Okay, because after t minus 4 its value is 0, so multiplication will be 0. So upper limit t decided by this signal, and lower limit is decided by this signal because before lower limit its value is 0. So this is defined, this value is defined for t greater than 4, as we already note here. So if you perform integration, you will get like this. So we have two output. For t greater than 4, its output is this. For t less than 4, as we already found that for t less than 4 its output is 0. So you can combine these two output by putting here u of t minus 4. Okay. So second method, this was graphical method. Second method is mathematical method. all steps are same, only you have to perform all above steps mathematically. You have to do integration only, so there is no much change. So here next thing is properties of convolution, because convolution is very important topic which will be useful for all other topics in signal system and in communication in other subject also. So properties of convolution, there are 6 properties. First is if you convolve x of t with del of t minus m, suppose, so then it will be equal to x of t minus m, means this t will be replaced by this t minus m. Okay, this property. Second property is x of t, this m and n here are order of differentiation. Okay? If x of t convolution with h of t equal to y of t, then x of t differentiated m times convolution with h of t differentiated m times equal to y of t differentiated m plus n times. Okay? This is true. Okay, because m and n are order of differentiation. Third property is if x of t convolution with h of t equal to y of t for any LTI system, then x of, which is true for any LTI system, then x of alpha t convolution with h of alpha t will be equal to 1 by mod alpha y of alpha t. Okay, this is also true. Fourth property is convolution of any two causal signal will be always causal. Okay, convolution of two causal signal will be causal signal. You can prove it by taking example. One causal signal you take u of t, second you take e power minus it, e power minus it u of t. You will get a causal value of causal signal. Okay, so next property is convolution of two anti-causal signal will be anti-causal. And last property is, it is important, that if y of t equal to x of t convolution with h of t, then area under y of t will be equal to area under x of t into area under h of t. Means area, if you for convolution of two signals, area will be multiplied. Okay, so this property will be useful in this question. So in this question is del of alpha t convolution with del of alpha t is equal to a into del of alpha t. We have to find here a value. Okay, so what will be a? Using this property we can find a. What we have to do, first of all, you have to, as we know, del of alpha t is equal to 1 by mod alpha del of t. So put here this value. Now you apply this property. Okay, suppose this is x of t, this is h of t, this is y of t. So according to property number 6, area under y equal to area under x into area under h. So area under y is, as we know that area of any impulse function is the coefficient of that impulse function, then the area is here a by mod alpha, and its area is 1 by mod alpha, its area is same 1 by mod alpha. So a will be equal to 1 by mod alpha. Okay. That's enough for today's lecture. I hope you will understand all the things I have explained. If you have any doubt, please write into the comment box, and if you have any suggestion, please write into the comment box. And if you like it, please subscribe for next lectures also. Thank you.